Hey guys, how are y'all doing? This is Ben Grice from Backcountry CAD, and I just wanted to, get a little bit more involved in the community that I already love, and I actually had the idea to bring you along in kind of my design process for the hammer. This has been one of my more popular products, and one of the things most I like about, modding Leathermans is the community behind them. I have people all the time reaching out to me to make custom tools, to make different combinations and kits and stuff for their Leatherman based off their job. And so this was actually months and months in the making to actually, get into a finalized prototype or finalized product. I mean, it wasn't as simple as just have an idea and make it. So I thought I'd actually walk you along in the process as to what this looked like. Now, I do make this for several tools. I have the Surge, the Wave Alpha, Charge TTI. I have the Skeletal. There's a lot of hammers that I make, but the premise applies to all of them. And so I carried a Leatherman Surge pretty heavily. And so based off just its weight alone, I was always using it like a hammer. I would hold it just like this and I would hit seized bolts, or I had 3D prints that would have press fits in them, or just things like that where I would use the weight. So I thought, you know what? I have a degree in engineering. I work full time as a design engineer. I bet I can come up with a product to actually help solve this problem. And so that's where I started with the very first iteration of the hammer. And so you'll see here, this was one that just mounted to the inside of the tool. I used to have a nylon bushing in here. I wanted to be able to drive a bit with it. And so I had like a bit driver thing here and a slot here. There's a few issues with this, and one of them being you might could put a bit here, but there's no actual way to retain the bit, meaning, it just slide or fall out. And so I decided to move on to my second version. Now, I used pocket clips for mine, not sheaths, so I added a little pocket clip cutout. And I used something called a spring ball plunger. It could be known as different names, but that's what I used. That way you could actually slide your tool in and it would retain it. But again, something I didn't like about this version made me want to move on to a new version, and that is one of the most heavily used tools on my Surge, besides some of the obvious like pliers or a knife, is I use the flathead on the inside a lot. So I wanted to design a version where it would slot around my flathead. Now, in my testing, this was structurally fine, but I just wanted to see if I could beef it up a little bit more, so I made the flanges a little bit thicker. But also, this was just for driving a bit. I didn't have a way to actually store the bit on board. This would retain it when it's in the end, but a bit wouldn't slide all the way into the end. So, again, I decided to iterate. And this was one of my favorite, let's call it milestones or versions along the way. I had a lot of fun making this one. I would use these spring ball plungers right here to actually retain the bit. You can see it'll snap into place. See if I can get it close to the mic and see if you can hear it. It can snap into place and then it won't come out. And if you press on the back of it, you can push it out. Now, this checked a lot of boxes for me in the beginning. It was pocket clip compatible. I could still use my flathead, but I just wanted to try a couple different versions. I knew this wasn't the final thing that I wanted to settle on, so I decided to play around a little bit more. So that's when I messed with a version like this. Now, having the two bits was fun, except for the fact that, you know, bit retention again became a problem. And so I decided to ditch this version, and based off of some feedback from people who were watching my progress, I decided to implement a 1/4 inch hex drive in this version. And so this was actually the first version I brought to market. So it attached to the inside of the tool, and it had a 1/4 inch bit driver and magnetic retention, as well as a little bottle opener. Now, it was pretty useful for a while, but I wanted to do something where you didn't have to sacrifice the tools on the inside of the Leatherman and give up functions that the tool came with in order to game my mod. So that's when I started on the road of the external hammers that you'll see on this side. Now, the first version was just very rudimentary. I combined some features I learned from the first go around, which is, the spring retention here, but I would attach to the outside of the tool, replacing these crowns like the ones you see here. But again, people wanted a hex driver for the tool, and so I made this hex driver. And along the process, there's a lot of other factors that don't get included when you just look at a top level view like this. But there's finish, quality, tolerances. So you can see from early versions to newer versions, the quality and sharpness and crispness of the hex. What I was working on increasing. The surface finish, I was working on, increasing the surface finish from early models to newer models. The tolerances, making sure no holes, holes were, more like ovals. So there's a lot of behind the scenes things that were also going on, not just design changes. But I decided to move on again. I knew I liked this design, but it sat up just a little too tall for me. These actually wouldn't fit in the Leatherman sheath anymore. So I found that there was enough engagement and strength in the steel that I could actually take away the bottom of it, and there was no way by hand you were actually going to round this out. So I decided I could lower the profile of the hammer a little bit by taking out the bottom of it. But yet again, I knew this wasn't the final version, just one that I liked, so I moved on. This is when I made the first feature that is similar to the hammer I have now, and that is the full-length cutout in this hammer that allows you to fully deploy your tools on the inside. This is when the hammer became what it is today. So you can fully deploy your tools on the inside, because in old versions you needed this cutout to actually have the clearance for the hammer. But again, there were a couple issues with this, and one of them being structural issues, or two, actual quality of life issues. Now, the Leatherman is bent sheet metal. Like, its whole frame is just a piece of sheet metal that's folded and bent. And these screws serve an important function besides just mounting your internal tools, and that's actually tuning the tension of your tools. So the Leatherman frame is like a C, and you have your internal tools. Well, the tighter you screw that screw, the tighter it's going to be to open and close your tools. But the looser you do it, the easier they will, flop around. So whenever you have a completely rigid side of this hammer, there's no flex or give to allow you to actually be able to modify that. So in some later versions, I messed with these cutouts. Now, there has been someone who bought my tools recently who bought them just to measure them and try to make an exact copy, counterfeit the mod, and sell it themselves. And they are missing some critical features that I'm guessing is because they just didn't have the ability to machine them. But whenever you have rigid sidewalls on your hammer, you can't have any sort of compliance in it to tune the tension of your tools. So you're able to, if you have just a perfect fit, maybe you can hopefully shim it, or you just get lucky that your tool is the right thickness exactly. But when you're bending sheet metal, there's no perfect tolerance for everything. Leatherman does a really good job and they get really close, but there's no perfect tolerance. You want to be able to have some compliance built in case even if you do have a perfect tool, your tools can loosen up over time. So that's when these slots were added in. Now these slots, I mean, they are extremely strong. People have seen them and think that they're a weak point. But if you'll actually note, the thickness of the steel here is actually double the thickness of the frame of the Leatherman itself. It only looks thin in comparison to this extra thickness flange here. It might be a weak point, quote unquote, but it's by no means weak. It's twice the thickness and made of solid steel of twice the thickness versus the frame of the Leatherman itself. Then there were a bunch of engineering problems to overcome. I didn't want people to mess up their tool over time. I don't want people to bend their bolts over time. Well, if you just have metal on metal writing on the frame, how do you keep it from scratching up over time? There's all these problems you want to solve for, not in just terms of function, but also in terms of durability and longevity. You want this to last a long time. Part of the reason people buy Leathermans over, copies from Harbor Freight or something like that is you want the build quality, you want the improvement, you want the warranty behind it, you want all these features. You don't want something that's not going to hold up to the test of time, like the tool itself. And so not only was the form an important part of the design, but actually testing it and designing for longevity, not just for function alone. And so all of this applies to my other tools as well. That's how we finally landed on this, where every bit of geometry that you might not think matters was found to be an important part of design over months and months and thousands of dollars of prototypes that were all self-funded. And this is only part of the equation. These are just the final versions of different versions of the prototypes. I'll actually drag in my little box here. Keep in mind, this is only about half of what I have, but I design a lot of stuff. Right now, I'm working on some stuff for some Benchmade bug outs. So I have handle after handle after handle that I am testing tolerances, strength, different retention mechanisms, and that's just on that one product. I have some scales that I'm machining for the Wave Alpha I'm testing for. But you can see this whole box of mods is just months and months of designing and prototyping and testing. Testing not just for function, but for final quality. There's surface roughness, there's things like this that take a long time to actually develop into a final product. You can see different versions of the utility knife, like old versus new versions, to actually see what cuts boxes the best, what looks the best, what interacts the best with the tool. So it's not as simple as just having an idea in your head and being like, oh, you know what? I'm going to make that and be done with it. So I hope you all enjoyed the video, learned something about it, and just generally enjoyed getting to be a part of the journey with me, because I know I enjoyed making it and getting feedback from all of you. If you have any questions, let me know. I'd love to answer them and just interact with y'all and see what you think. Thank you.